Now, in this session, we're going to continue solving the equivalent resistor for this network, the second network. In the previous session, we have solved this one. Now we're going to solve this. Here, we have many branches connected in this network, and then our aim is to find the R equivalent, RAB, looking from this A and B here, R equivalent. And then if you look into this, we have 20 ohms and 5 ohms connected in parallel. If you solve this, you will get one value which will be connected in series with 1 ohm. And then later on, again, if you solve this equivalent value, then it will come in parallel with the 20 ohms. So in this way, we have to solve the equivalent resistors which is connected in the network. Okay, let's solve with that one. Okay, we solve this, and then that 20 ohms which is connected in parallel with the 5 ohms, we got it 4 ohms. Now here we had sorry, we had the two resistors connected in parallel. We solve this using this equation, using this formula. Okay, anyway, this one 1 by RT is equal to 1 by R1 plus 1 by R2 plus so on. We solve that one, and we got the equivalent resistor 4 ohms. And now we can solve this 4 ohm plus 1 ohm is connected in series. So 4 plus 1, okay, 4 plus 1, which is equal to 5 ohms. So we can replace this 5 ohms, this 4 plus 1 ohm, with the 5 ohms. Okay, then we have to redo the circuit. Okay, it looks something like this. Okay, now in the next step, again we have 20 ohm is connected in series with the in parallel with the 5 ohms. Again, we can solve similarly here. 20 ohm is connected in parallel with the 5 ohms. So the equivalent resistor for that one is again 4 ohms. We get 4 ohms. Now, which means again we can redo the network. And then we got it. Then we got it 4 ohms. Now this 4 ohm is in series with this 2 ohms. So I can write here 4 ohm is in series with the 2 ohm. So we have 6 ohm. Now this one again we can replace it with the 6 ohm. So we delete these things again. Okay, this way to connect like this. Okay, now here the equivalent resistor is you have 6. You have 6 ohms, and then that 6 ohms is connected in parallel with the 9 ohms. So we have to calculate the equivalent resistor for 6 ohms connected in parallel with the 9 ohm. Okay, is given by 6 parallel 9. So you'll have 6 times 9, 6 times 9. So equivalent resistor is 3.6 ohms. Now we can again replace, we can simplify this network and then replace it with the 3. Okay, we have to delete this, and we have to delete this, and then this also. Okay, and then we have to replace it with 3.6 ohms. Now again we have 2 more steps. That is, we have to calculate this 18 ohms. 18 ohms is in parallel with the 3.6 ohms. So we'll get 18.3 ohms parallel with the 3 ohms. We'll get, okay, 18 plus 3.6 is equal to 3 ohms. And then we got the final simplified network, okay, which will look something like this. And then it is 3 ohms. And then our final step is 8 ohm is in series with the 3 ohms. So we have 11 ohms. So equivalent resistor for this one is 11 ohm for this network.